Understand the solution to exercise 5, I'd like to present an important idea for something called binary search in software engineering and really computer science. And we're going to talk about how it's going to help us to guess the number that the user is thinking of. So binary search is sometimes known as a divide and conquer approach. We're going to be taking our problem, we're going to be dividing it into smaller pieces, and we'll be trying to find the answer as quickly as we possibly can. The reason it's called binary, it really has to do with the bi, i.e. the half that we're doing it, or two, or splitting the problem in two each time that we're going to be looking to dig deeper. We have a really big space, numbers 0 to 100. We're going to try and find a way to split the problem into smaller and smaller pieces until we get to the right answer. So how does this work? Imagine we start with the number 50, and we get to make a choice. We get to ask, is the number correct or not? So you get to tell me the number I'm thinking of is smaller or it's bigger. Great. If you tell me that it's smaller, i.e. between 1 and 49, then that informs what number I'm going to choose next. So the easiest number for me to choose next is the middle between 1 and 49. I'm splitting in half that range of values. So now I get to ask the question again, is it smaller or is it bigger? It could be bigger, it could be smaller, it doesn't really matter. But it informs us our next decision, i.e. are we going to go to the right, i.e. somewhere between 26 and 49, 33, or to the left between 1 and 24, and that's really 12, and that's going to be our next guess. And eventually we're going to get down to only one or two choices, and that will be our answer, or we would have gone to the correct answer in the middle. What we're doing each time we're doing this process, we're cutting the problem in half, and we're getting closer and closer to the right solution. It could be that we actually make the right guess when we cut in half, the next half is the right answer, or it could be that it's in a smaller space. Eventually, there's only one option. You only get down to one number that is could be without cutting the problem any further. So that is the idea behind binary search. We've seen roughly how it works. We've seen how the divide and conquer approach works. And now we can take this idea, we can translate it into code. And with the actual solution for chapter 3, exercise 5. So the things we're going to use an int guesses is going to be 0. And we know that it's going to be limited to 7. We'll talk about that a little bit later on. We're going to start with a lower bound is going to be 1, and int upper bound is going to be 100. And then we're going to write our basic loop. I like to do this, also let's go ahead and do this bool guessed is equal to false. And so what we're going to do is like this, while guesses is less than 7, and guessed and not guessed. And I know we haven't looked at compound statements here in the while section, but this is a great opportunity to say this is the left side is true and the right side is true. So while we haven't found a guessed answer and the number of guesses is less than 7, we're going to run in the loop. So what's going to be our first going to be the process? So first I'm going to say is int guess, and the way we're going to calculate the guessed is like this. We're going to say upper bound minus lower bound, at least initially, divided by 2 plus the lower bound. And then we're going to say like this, standard cout is the number you are thinking of, and we're going to say guess, and this should print out 50. And we're going to go ahead and grab the answer in. So we'll say we're going to have a character input, and we're going to call it, and we'll just call it input. And we're going to say standard cin into the input. And let's go ahead and give some users some guidance. Standard cout, please choose C for correct, H for too high, and L for too low. Right, we got this right, we missed something right. So we're going to choose C if the answer guess is correct, H if the guess is too high, or L if the guess is too low. So let's go ahead and do this the easy way. So if input is equal to C, well, then we're done, right? So we're going to say guessed is equal to true. We just guessed the number, and we're going to go ahead and the loop at that point will finish, but we'll go ahead and just do the printout and say standard. Actually, we can do that later on. We'll see if we do that though. Else, if input is equal to age, the guess is too high, then what we want to do is we want to set our upper bound to the guess, and we can actually set upper bound to the guess -1, and then the loop is going to go through again, and we'll go ahead and increment our, actually we can do that later on in a second, and else we know that it is too low, so we'll say that our lower bound is equal to guess +1. And over here we'll go ahead and increment guesses. Okay, and then over here we're going to come out and say if guessed, then we'll say that means we got to the right guess. We'll go ahead and print out standard cout. Yay, we guessed the right number, and we'll go ahead and print it out as guess. I see what's the problem. We actually divided here, so we'll go ahead and put it into here as well, and guess, and we'll initialize it to 0. Else, we did not guess it, so we'll just say something like this, ouch, we'll try again next time. And let's go ahead and see how this works. Okay, let's go ahead and run the code. And I'm thinking of the number in the number in my mind. I'm going to announce it now. I'm thinking of 72. Is the number you're thinking of 50? No. So the number is too low. And now it's going to say, well, is the number you're thinking of 75? No, because I'm thinking of 72. So I'm going to say H for too high. So I'm going to say, is the number thinking of 62? No. I'm going to say, no, this is too low. So it's 68, still too low. 71, I'm going to say, still too low. And then 73, I'm going to say, yes, that's too high. And I'm going to say, is it 72? I'm going to say, yes, that is correct. And yay, we guessed the right number. Oi, we got the wrong solution here. Let's go ahead and fix that. We'll see why that is. So if guessed is true, well, that's because we are overwriting the value. We just have to do it like this. And now this will fix it. And let's go ahead and just do that one more time to make sure that works. And we'll go ahead and this time we'll think of, let's say, 23. 23 is the number I'm thinking of. I've announced it. So the number is too high. 25 is too high. 12 is too low. 18 is too low. 21 is too low. And 23 is the number I'm thinking of, so C is correct. It's going to say, yay, we guessed the right number, 23. Great, so the program works. It looks like it's doing the right thing, and we'll go ahead and ship it.